Okay. So one of the um, one of the irrational numbers that's important in many areas of science is the number e. Okay, so notice I said the number e. Okay, the number e. That's an important number. It's an irrational number, by the way. This is irrational. That's why we're using a letter to represent that number. It does mean something. When you get into calculus, you're going to see what that number means and how it came about. We don't have the time in here to actually look at the pattern where this comes from. But this is an irrational number. E is an irrational number. And in fact, on your calculator, I want you to do this on your calculator. I want you to tell me what E squared is approximately equal to on your calculator. Now, here's how you get it. Okay, so you right above the ln button, and by the way, ln is a log function, log. We are going to talk about that. But right above the ln button, you'll see that blue symbol that looks like e to the x. Okay, so e to the x. You see this. All right, I want to find out what e squared is approximately equal to. So you're going to, using this particular calculator, you got to do the e to the x first. So you're going to press second, e to the x. Oops, sorry, I did the wrong one. So second, ln. You see how it shows that e raised to some power? What do I put inside that parentheses? 2. I'm going to press equal. I do not need to close it in this particular case, but you can if you want to. You can close that parentheses. When I press equal, I get this irrational number. So 7 point, and they're going to ask you to round to 3 decimal places. 3 decimal places. So to 3 decimal places, that's 7.389. Okay? So that's about equal to 7.389. But in particular, though, you really need to know what number E represents. Okay, so I'm going to ask you this. What is E approximately equal to? Now, that's the important number right there, because that's going to plays quite a bit in engineering, in science courses, in math courses as well. So if I want to find out what E is approximately equal to, what's that exponent right here? 1. So I'm going to say second. Oops, let me clear this. I'm going to say second e to the x. I'm going to press 1, press equal. To 3 decimal places, what is E approximately equal to? 2.718. 2.718. That's what E is approximately equal to. Okay? E to the first power in your calculator? Were you able to do E squared? Well, same thing. Did you get a different answer or something? Is that what you're asking? Okay. All right. So what's E approximately equal to? 2.718.
Always. That's what you.
Well, yeah. I mean, if you put E to the first in your calculator, you think you can get a different answer?
No.
Okay. So yeah. All right.
Just my brain knows what to do, that's a letter.
Okay. So E is a number.
He's a number.
If you keep putting E to the first, you're going to get the same thing.
Over and over.
Okay? All right. So E is approximately equal to 2.718. All right. Now, before we go on to what I really want to talk about, though, let's graph that exponential function, e to the x. So let's go ahead and graph that. Y equals f of x equal e to the x. Okay? All right, now. Okay, so we're going to graph f of x equal e to the x, and we're going to do the same way we did those 4 or 5 problems we did earlier today. We use a t-table. Now, what kind of function is this? exponential. So right away, you can tell me several things without even graphing anything. You could tell me the domain. What's the domain? Do you remember? All real numbers, because I can use any number for x and I'll get a y value back. So when we do that t table, you'll see that I can let x be any number I want to, and I will get a y value. You could also tell me right away what the horizontal asymptote is. Yeah, because there's no constant out here, right? So if this was e to the x minus 3, then your horizontal asymptote would be y equals negative 3. Okay? All right, so the horizontal asymptote is y equals 0. Now, what axis represents y equals 0? The x-axis. So I'm going to go ahead and draw a dotted line. Now, remember, as I was going around, some of you are not drawing your horizontal asymptote. You have to draw your horizontal asymptote, and you draw your horizontal asymptote using a dotted line. So I'm going to draw my horizontal asymptote. It's going to be the x-axis and put some dashes. I'm going to put dashes on the x-axis just like this. Okay? All right, and then use the t-table. You should always let x be what first? 0. There are a couple of you that did not. I was like, well, why aren't you letting x be 0? Because what is it you're finding when you let x be 0? The y-intercept. All of these are going to have a y-intercept. We talked about that fact. Find it. Okay, so if we let x be 0, I get y equals e to the 0. What's e to the 0? 1. So there's your y-intercept. Your y-intercept is 0, 1. Now I'm going to ask you this other question. Right off the bat, you didn't even have to graph anything. You could answer this question. Is my graph going to be an exponential growth or an exponential decay? A growth, because e is the base is bigger than what? No. 1. It's bigger than 1. Remember, if it's less than 1, it's an exponential decay. So it'll be an exponential growth, so I know that I'm going to get something that's going to rise very rapidly on this side. So if x is, let's say, 1, I get y equals e to the first, which I now know is approximately equal to what number? 2.718. So it's close to 3, right? So just approximate. Now you're going to be approximating these. So about 2.718. So 1. So it's close to 3. So about right here. Just approximate. Just approximate. See what I'm doing? Approximate. If x is 2, I get y equals e squared, which I already found, right? That was what? 7.389? Which is a little bit above 7. So 7.389 is about here. And really, that's all you need to do. Because look, now look how I'm drawing this. It's a curve that's rising rapidly, just like this. Now, again, I could have done a better job of that, but that's what we get. And on the other side, it's getting closer and closer to the the x-axis, because that's a horizontal asymptote. So yes, and just do this. You're done. Okay, so that is the graph f of x equal e to the x. Okay. What's the range just from the graph? 0 to infinity. Bracket 0 or parentheses 0? Parentheses 0. Okay? All right. Any questions? Okay. All right. Now, let's talk about this now. Okay. So, listen carefully. Listen carefully. Here's the problem. So these are going to be some application problems. All right, application problems. So let's suppose that you deposit $2,000. Some of you are like, well, if I have $2,000, you deposit $2,000. What?
Never seen that much money in my life.
I know, right? $2,000 into an account. Write this down. Into an account, paying. Now, really, you know, the savings accounts, the interest rates are pretty low, so it's not. It's probably less, about 1% or 1.5% or something like that. I don't know what it is, but it's not high. Paying, let's say, 4% annual interest, compounded quarterly. So I'm going to do A quarterly. How much money is in the account? How much money is in the account after 5 years? How much money is in the account after 5 years? All right, so you have $2,000 and you're putting it into some account. What's the interest rate on that account? 4%. And you're going to leave it in there for how many years? 5 years. Now, guys, that's assuming you don't take anything out and you don't put anything in, which is not realistic, right? You take things out of your accounts all the time, but let's assume that that's what's happening here. Okay, what we mean by compounded, if the interest is being compounded, what that means is that interest, if you don't take anything out, that interest is also earning what? Interest. That's what that means. Compounded, that's what that means. Your interest is earning interest. So if you have $2,000 in your account, after 5 years, it's going to be more, right? Why is it more? If you don't put anything in, where's that extra money coming from? The interest. That interest is also earning what? Interest. Okay? All right. So, there's a formula you're going to use for this, and here's the formula. A equals P times 1 plus R divided by N, all raised, and the exponent is going to be NT. A equals P times 1 plus R divided by N, all raised, and the exponent is the product of N and T. Okay? It's an easy formula to use. You just plug and chug in your calculator. But you got to know what those letters stand for. So P is the initial amount, sometimes called the principal. The initial amount that you put in, or the principal. So in this particular case, what number would represent P in this case? 2,000. Okay, good. R kind of makes sense. What do you think R stands for?
Rate.
The rate. And the rate must be listed as a decimal. So that's the interest rate. Interest rate. And it must be as a decimal. So from a previous course, you know that 4% as a decimal is what? 0.04. Okay. T is kind of easy to figure out. What does T stand for? Time. And time must be in years. Time must be in years. So if I tell you 6 months, then what is that in years? 1/2. Because remember, you say 6 divided by what?
12.
12, which is 1 half. Because there are 12 months in a year, right? So that's how you convert months to years. You divide by 12. So if it's 24 months, if I say 24 months,
2 years.
yeah, because you say 24 divided by 12, which is 2. Okay, now let's talk about N though. I saved N for last. Well, A is the amount you end up with. The amount, A's amount. So the amount in the account. Let's talk about N though. So N, listen carefully. Listen carefully to this. N is the number of times interest is compounded per year. The number of times interest is compounded per year. Okay? We're talking about just 1 year. So listen carefully. There's only a few things you need to remember. If you're told that interest is compounded monthly, then N is going to be what? 12, because there are 12 months in a year. If you're told that interest is compounded semi-annually, twice a year, meaning every 6 months, so N will be 2. If you're told that it's being compounded quarterly, then N is what? No, 4. There are how many quarters in a year? When you think of quarters, just think of a dollar. How many quarters are in a dollar? 4. So quarterly means you divide that year into 4 parts. Remember quadrants? In the word quadrant, don't you see QUAD? QUA? Okay? So that means every 3 months. And the other one is annually. N is 1. You may see this one though, but you may see this one, daily. We're assuming we're not in a leap year. N is 365. So that's about all you need to know for N. Monthly, semi-annually, quarterly, annually, daily. I'm not going to give you one with daily. Now, let's go to number 1 now. Okay, number 1. So you deposit $2,000 into account paying 4% annual interest, and it's being compounded A, and what's A here? Quarterly. So part A is quarterly, but for how many years? 5. All right, so let's use the formula. By the way, in terms of the formula, which of these letters am I looking for in this case? A, looking for A. So A equals P, what's P? 2,000, so 2,000 in parentheses. 1 plus R, what's R? Tell me what R is. 0.04. Don't say 4, because your rate must be listed as a decimal, so you must change 4% to a decimal. So it's 0.04 divided by N, what's N? Quarterly means 4 times a year, right? 4. All raised to, and I'm going to put the exponent in parentheses, because when we put in the calculator, you're going to really need to do that. So NT, what's N? 4 times T, what's T? 5. Okay? All right, let's use your calculator. Listen carefully. Make sure you get this in your calculator. Now, did y'all have any difficulty plugging in? No, everything was there. You just put the numbers in the right place. Okay, on your calculator. As you read the formula, as you read what you see, you type into your calculator. So look, what do I type in first? 2,000 times. What do I press next? No. Parentheses. What do I type in next? 1. Next. Plus. Next. 0.04, next. Divided, next. 4, next. Parentheses, next. That button here, okay? Next. Now you can say 20, or you can say parentheses, and then what? 4 times 5, and then close, and then press equal, and that's what you see. Now, listen, you're dealing with money, right? When you deal with money, you always round to the hundredths place. So what's the answer here? $2,440 and what? 38 cents. So this is going to be $2,440 and 38 cents. So about how much money did you make on that $2,000? About $440 and 38 cents. That was your interest. Now remember, we're assuming we didn't put any money in, we didn't take anything out, which is not realistic, but you know, we're just working math problems. Okay, let's do B. B. So it's very easy to use the formula. All right, B, let's suppose it's semi-annually this time. Same information, except this time semi-annually. Okay, semi-annually. All right. A equals, what's P? 2,000 times 1 plus R, what's R? 0.04 divided by N, what's N? 2, semi-annually, 2 every 6 months. All raised to the N, which is 2, times T in how many years? 5. All right, and you just put in your calculator and you're done. Okay, so in your calculator you're going to say 2,000 times, what do I type in next? Parentheses, what do I type in next? 1 plus 0.04 divided by 2, close parentheses, raised, and you can say 10 if you want to, right? So I'm just going to say 10, because you all know that 2 times 5 is 10. Enter, and you get how much money? Yeah. Okay. So about how much money did you earn in this case? About $437. Okay. Now, I want you to notice something. Did you make more if it's compounded quarterly, or did you make more if it's compounded semi-annually? Quarterly. Why does that kind of make sense that you would earn more quarterly? Because the interest, remember, interest is earning interest, right? So your interest is being compounded more quarterly in those years than semi-annually. Semi-annually is just how many times a year? Twice. Quarterly is 4 times. So your interest is earning even more. So the more times it's being compounded, the more you would get. So based on what we talked about then, just for that same problem, which one would give us more money? Daily. Daily would give you more money. Okay? All right. Any questions? Okay, let's look at this one. There's number 2. So I'm trying to do enough of those to where you could actually do that worksheet that I just passed out. Because they usually have one like that on the final. Not always, but sometimes they do. So let's look at this one. Number 2. Suppose you invest $6,000 compounded monthly for 6.5 years. The interest rate is 3.25%. 3.25%. How much money will you have in the account after 6.5 years? So you invest $6,000 being compounded monthly for 6.5 years. The interest rate is 3.25%. How much money will you have in the account after 6.5 years? Okay? So A equals, what's P? 6,000 times 1 plus R. The rate's 3.25%, but you got to write as a decimal, so what's that? How do you, guys, you've got to remember how to change a percent to a decimal. Move the decimal point 2 places to the left. So 3.25% is what? 0.0325, right? Divided by n, what's n in this case? How many times being compounded a year? How many times being compounded, would you say? No, n. I'm talking about n. 12. 12. Raised to, in parentheses, n, what's n? 12 times t, what's t? 6.5. All right, let's put that in a calculator. So on your calculator, you're going to say 6,000 times, parentheses, 1 plus 0.0325 divided by 12. What else must I do? Parentheses, close the parentheses. Now I'm going to raise it, and then I'm going to put parentheses. And then for that exponent, what do I type in? 12 times 6.5. Don't forget to close it though. And then press equal, and that's what you have. So the amount after 6.5 years, and remember we're talking about money, so always round to the nearest hundredth. So $7,409.21. So, so you made it. You made above in terms of your interest. You made above $1,400. Okay, questions on 2? Just plug and chug. All right, now listen to this one now. Number 3. Number 3. Okay. Suppose you invest $3,000 in an account paying 2% interest continuously for 4 years. How much is in the account? How much is in the account after 4 years? So you invest $3,000 in an account paying 2% interest, compounded continuously. That should say compounded continuously, by the way. Compounded continuously for 4 years. How much is in the account after 4 years? All right, now, the key word here is it's being compounded continuously. compounded continuously. When the two problems we just talked about, those were being compounded either 12 times a year, 2 times a year, 4 times a year, 1 time a year, 365 times a year. That's a finite number. Okay? Continuously, think about the word continuously. Continuously means all the time. So think of the word infinite in that case. Okay? So there's a different formula you're going to use for that one. If they use the word continuously, here's the formula you're going to use. And it's easy to remember because there's a shampoo named after it. PERT. P-E-R-T. No, it's not really. They didn't. The company didn't name the shampoo after this formula, but so A equals P. Now remember that irrational number we talked about earlier? What was that number? E. A equals P times E to the RT. So your exponent is RT. So you're going to use PERT when your interest is being compounded. What's the word? Continuously. So you can use this if compounded continuously. All right, so let's plug in. So I'm going to use A equals P times E to the RT. All right, A equals P. What's P in this case? 3,000 times E. All I'm gonna put RT in parentheses. All raised to the R. What's R in this case? 0.02 times T, and what's T? 4. Notice that in the previous problem was R in the exponent when it's compounded finite number of times. No. But since R is in this formula, it's a good idea when putting your calculator to put parentheses for the exponent. All right, so what do we do? You're going to say 3,000 times E. Now, how do I get to that E? Second ln. It automatically puts a parentheses there. So what do I type in next? 0.02 times what? 4, and then what must I do? Close, and then press equal, and you get $3,249.86. Okay? So any questions on those two formulas? Those are easy points to get, by the way. Because if it says continuously, you know which one to use. If it says quarterly, monthly, you use the other one. Okay? All right, so let's look at that worksheet that I gave you. All right, so that will be the end of this particular part of the lesson.